Namaskar, my dear students. Today we are going to discuss about the first lesson of class 10 compulsory maths. In the first lesson in compulsory maths of class 10, there is a lesson is set. So today we are going to about the first class of set. In this class, we will discuss on these topics: the concepts of sets, disjoint and overlapping sets, cardinality of sets, and establish the relation using cardinality of sets by showing disjoint and overlapping sets in the Venn diagram. So let's now review. First, we have to review on sets. Why I am saying that review on sets? Because the students, you already learned about the sets in the previous class also. It means class 8, class 7, class 9, isn't it? So that's why today first we have to review on sets. So now here, some objects we are going to collect. So the here objects are here in the box. They are the some objects are there. Yes. So the properties of these objects, we can make the sets from the above these objects according to their properties. So how many sets we can make? Let's see now here. So how many sets we can make here? Yes, how many? 2 sets we are going to make here. Yeah. So what type of sets are there? The first sets, the content, the objects. What are these objects? Yes, these objects are the vegetables. Yes, because here is what? Cauliflower is here. Next is what here? Cabbage is here. Next is what? Tomatoes. So these are the vegetables, isn't it? Yes. Now second set, let's see the second sets. In the second sets, what objects are there? Yeah, in the second sets, the objects are mangoes, apples, orange, and banana. So these objects are what? Yes, that is the fruits. Yes. So now here we have to make the 2 sets where one set is what? Vegetable, and other sets are is what? Fruits. So that's why what you say that the first set is the set of vegetables and second set is the set of the fruits. So from the collection of objects we have to make the 2 sets. Yeah. So this set of the vegetables, that is well defined, because we can say that this is cauliflower, this is cabbage, and this is the tomato. So it is well defined. Similarly, in second set, there are the fruits, that is also well defined, because the name of this fruit is what? Mango. The name of this fruit is what? Apple. The name of this fruit is what? Orange. And the name of this fruit is banana. That's why what we can say that? We have to say that a set is a collection of well defined objects. Yeah. And in the set of vegetables, these cauliflower, cabbage, and tomatoes are called what? These 3 are the members of the set of the vegetables. So we can say that the objects contained in a set is called the members, or we can say that the elements of the set. Similarly, in the set of fruits, what are there? Mangoes, apple, orange, and banana. So these 4 are the elements or members of these sets. Yeah. Okay. A set is represented by the capital letter of English alphabet. Yes. So this is the set of the vegetable. So this set is denoted by which letter? The first letter of vegetable is what here? V. Okay. So we can say that the set of vegetable and set of the apples, fruits. Yeah. So the first letter of vegetable is V. That's why we can say that here set of vegetable is denoted by V. Then we can write the set V is equal to curly bracket cabbage, cauliflower, and tomatoes. Why? These 3 these three vegetables were contained in the set of the vegetables. So these are the members. So the sets which we have to write in this form, that is called the listing method of the sets. Yeah. Similarly, set of the fruits is denoted by F. Why? The first letter of fruits is what? F. So denoted by F. So, and the set of the our fruits, how many members are there? 4 members. That 4 members are mango, apple, banana and oranges. So that's why set F is equal to curly bracket mango, apple, banana and oranges. So in this way we have to represent the set which we form. Yeah. Okay. Now the above two sets we are going to shown in the Venn diagram. So in a Venn diagram, let's see here Venn diagram. In the Venn diagram there is a rectangle box. Yeah, the rectangle box denote the universal set. So it is denoted by U here, and the first set is set of the vegetables, isn't it? Yeah. So in the Venn diagram, the set of the vegetable is denoted by circle, and that set, how many elements are there? 3 elements. That is what? Cabbage, cauliflower and tomatoes. So that's why these 3 members are here: cabbage, cauliflower and tomatoes. Similarly, next set is what? There is set of the fruits, isn't it? Yeah. So set of the fruits, how many elements are there? How many members? 4 members. That is what? Mango, apple, banana and oranges. That's why the set of the fruits is denoted by next circle, and it is denoted by F, and the elements contained in that sets is apple, mango, banana and oranges. So in the Venn diagram, the set is shown by circle, or we can use the oval shape also. Okay. So in the above two sets V and F, in these two sets V and F, there are any elements are common? No. So what to say that there are no any common elements in these two sets. It means what? Set V and F are not overlapping sets. Then what happened that these two sets are disjoint sets. So therefore these two sets are disjoint sets. Are you clear or not? Here set V, here set F. These two sets are different sets. There is no any elements are common. So these two sets is called the disjoint sets. So from this example, we can define the disjoint sets like this. Right? Disjoint sets means what? If 2 or more than 2 sets do not have any common elements, then the sets are called disjoint sets. Yeah? So this is clear from this example, isn't it? Here set V and here set F. These two are different sets are there. There is no any common elements. So from this example, it is clear that disjoint set is a set, yes, which is formed from the 2 sets or more than 2 sets, whereas there is no any common elements. Now the same 2 sets are here V and F. So in set V, how many elements are there? Please, can you say that? How many elements are in set V? Yes, in set V there are the 3 elements, isn't it? How many elements? 3 elements. So what we say that the number of elements in set V is 3, and what we can say that the number of elements contained in a set. Yes, very good. That is called the cardinality. Okay, then we can say that the cardinality of set V is 3, and symbolically it is written as n bracket B is equal to 3. So this is the symbol of the cardinality of the set. So n denotes the number, and we can say that in the set it is called the cardinality. Cardinality means what? Then number of elements contained in the set. Okay. Similarly, in set F, please can you tell me now how many elements are there? Oh, good. in the set F there are the 4 elements. Yes. So we can say that the cardinality of the set F is 4. So symbolically we can write n bracket F is equal to 4. Yes. Look at the cardinality of set F is 4, and symbolically it is written as n bracket F is 4. Okay. So from this example, what we can say that how can define the cardinality? Look at cardinality of set. We can define the cardinality of set is defined as the number of elements in a set. Yes. Now in these two sets, set V and set F, there is no any elements are common. Yeah. So what is the union of these two sets? So union of these two sets V and F means what? The curly bracket, the elements contained in set V and the elements contained in set F we have taken together. So look at here, union of set V and F is equal to curly bracket, cabbage, cauliflower, tomatoes, these 3 elements in set V, mango, apple, banana, oranges, these 4 elements in set F. So that's why the union of set V and F is this. The union of set is denoted by symbol U, this. So we can write V union F is equal to cabbage, cauliflower, tomatoes, mango, apple, banana, oranges. And these two sets are what type of sets are these two sets, please? Yeah, these two sets are, we said that disjoint set, isn't it? Okay. So what we say that union of sets means the union of two sets is an operation of set, that is operation of sets. Yeah. That forms a set. It means according to this operation we form a new set, just like now here set V and set F. From these two sets we form the new sets or not, that is V union F. It means what? A new set which is formed by the operation, that is known as the union of sets, that containing all elements that are in first set or in second set or in both sets. Both sets means what? If the sets are overlap, it means if the sets where the some elements are common, that is known as the both, its meaning is in the both. So if A and B are two sets, then the union of set A and B is denoted by A union B. From this example, what we say that union of two set B and F is what? B union F. Yes, if the set is denoted by A and B, then we can say that A union B. So it is clear, union of sets. Yeah. So what is union of sets, please? Yeah, union of set is a operation of sets. Due to that operations, what we can do? We have to form the new sets, isn't it? Okay. Okay, now from this example, we have taken the same Venn diagram where the two sets B and F. Okay. Before we discussed about the union, isn't it? Here, B union F. So in B union F, how many elements are there? Look at here. How many elements are here? Cabbage, cauliflower, tomatoes, mango, apple, banana, oranges. Altogether, how many elements are there? 7 elements. Yes. So what we say that? It means what? Cardinality of the B union F is equal to 7. Okay, let's see here. So cardinality of B union F is equal to 7 because there are 7 elements are there. Yes, but this 7, can you write 3 plus 4 or not? But you can say that we can write 2 plus 5 also. Yeah, 2 plus 5 also 7, isn't it? Or we can say 6 plus 1 also 7. But here I am written that 3 plus 4. Why? Yes, because why? We are taking the example is what? This Venn diagram. In this Venn diagram, first set is V, where how many elements are there? 3 elements. And second set is F, where how many elements are there? 4 elements. So that's why I am taking here 3 plus 4. So 3 plus 4 is 7. So, and 3 is what? Cardinal identity of set V. That's why NV, and 4 is the cardinal identity of set F. So, that is denoted by NF. That's why from this, what you say that? Cardinality of two disjoint set is equal to what we got? Sum of the cardinality of two different sets. Okay. It's clear now, yeah? Okay. So, there are no any common elements in set V and F. So, the intersection of set V and F is null set. In these two sets, set V and F, there is no any common element because these two sets are, whatever set is that? Disjoint sets. So, there is no any common element in set V and F. So, the intersection of set V and F is null set. But do you know what is the other name of the null set? What we say the null sets? Yes, the null set is known as also the empty sets, isn't it? Empty sets, because the set we cannot form from the common element of the set V and F. That's why it is the empty sets. So, therefore, the intersection of set V and F is called to curly bracket only. There is no any elements. So, the symbol of intersection is denoted by opposite U, this, or we can say that what? Cap. Yes. Therefore, V intersection F is equal to curly bracket only. There is empty, no any elements. Yeah. Okay. Now, from this example, we can define the intersection of sets. Yeah. So, the definition of intersection of sets we can define like this: the intersection of two given set is an operation. Yes, that is what? Operation, like union. Union is also what? Operation of sets. Similarly, intersection is also the operation of sets. Yes, set forms a set of those elements which are common to both sets. Yes, if there is no common, then what happens? Intersection is what happened? Yes, we already discussed. If there is no common, yes, then the intersection of that two sets is empty sets. So, we have shown here before, B intersection F is equal to empty sets. So, if A and B are two sets, then intersection of sets A and B is denoted by A intersection B, or we can read as A cap B. And in this case, the cardinality of set B intersection F is 0. Why? Why cardinality of set B intersection F is 0? Please. Why? Because here intersection of set B, this set B and this set F is what? Here. Look at what is that? What type of set is that? Yes, that is the null set, that is the empty sets. That means what? Yes, that set do not contain any elements, isn't it? That's why number of elements in the set B intersection F is how many? Good, that is 0. Yes, that's why you can say the cardinality of set B intersection F is 0. Good. Therefore, N bracket B intersection F is equal to 0. Good. Okay. Here some terminology we use in the sets that let's see now here. I have shown here two Venn diagrams. One Venn diagram is this, that is formed from the two sets B and F. Yes, and another Venn diagram is this, that is formed from the two sets A and B. But let's see, these two sets, these two Venn diagrams are here. Yes, and these the sets are formed. One set is this and other set is this, isn't it? Okay. Then what do you get the difference in these two Venn diagrams? Please, what do you get the difference in these two Venn diagrams? Can you tell me? What difference? Yes. Yes, very good. In the first Venn diagram, what happened that? Two sets do not contain common elements, isn't it? Yes. So that's why set V and set F are different. Look at set V is this, set F is this. But in next Venn diagram, there is two sets where one set is overlapped by another. It overlap means what? Look at this part. This part is what? Contained in set A also, and this part is contained in set B also, where one element is 2 there is. Yes. So this set, this is the example of what? Good. That is the overlapping. Overlap. Isn't it? Some part of set A and some part of set B is overlapped here. So this set is called the overlapping set. And but this set is called the disjoint set, because here sets are different. And elements of set B and elements of set B only. What do you know about it? Elements of set B, this set B, and elements of set B only in this case. Yes, its meaning is what? Both are the same, isn't it? Elements of set B is what? Cabbage, cauliflower, tomatoes. And elements of set B only is what? Also the same, because there is no overlap here. But in this case, what do you say there? The elements of set A and elements of set A only are same? Good, not. Why not? So elements of set A means what? Here two sets, two elements, 2 and 7. But this part is called what? This part. No, this part is the part of the only of set A. So in this part, one element count here 7. So that's why elements of set A only means what? 7. One element is here. But elements of set A means what? These all 2 and 7. So that is that. Elements of set A and elements of set A only. Yes. So this terminology we have to use while we are going to discuss the problems of the exercise also. Yeah. So this overlapping and disjoint clear? Overlapping means what? If the one set is some part of the one set and the some part of another sets are overlap, then that is overlapping set. Yes. Disjoint set means what? The sets which are the different. Just here B and F are different or not, because B is the set of vegetable and F is the set of the fruits. Both different or not? Yes. And elements of B clear now. Elements of B means these 3. Elements of B only also same in this case. But here elements of A is 2, 7 and elements of set A only 7. Yes, clear now. Okay. So from the above example, we conclude that if A and B are two disjoint sets, we give the example of the disjoint sets is what? B and F. Yes or not? Yeah. So from this example, we conclude that, and the set is denoted by in place of B is A and in place of F is B. Then what do you say that? The cardinality of A union B is equal to cardinality of A plus cardinality of B, because we show that cardinality of, if the B and F are disjoint, then cardinality of what? B union F is what? Cardinality of B plus cardinality of F or not? Yes. By the same way, here is that. Similarly, now next, N not A means what? N A. Just like there is only B and B are same. So similarly, here is A and B are disjoint. That's why N not A means what? N not A means only set A. Cardinality of set A only. And N A means what? Cardinality of set A. So both are the same. Similarly, cardinality of set B and cardinality of set B only are also here same, because A and B are disjoint. That's why N not B means what? Cardinality of set B only, and N B means what? Cardinality of set B. If universal set U contains only the elements of two disjoint sets A and B, then cardinality of U is equal to cardinality of A union B, because universal set U denoted by U, yes, and that set contain two disjoint sets A and B, yes, contain only that elements of two disjoint set A and B, other not elements are there. Then cardinality of U means what? Cardinality of A union B. That's meaning is what? The cardinality of A plus cardinality of B. But if universal set U contains other elements also, yes, other elements also, except the elements of two disjoint sets A and B, in that case, what do you say that? Cardinality of U is equal to cardinality of A union B plus cardinality of A union B. What this? What is the meaning of this? Do you know? Complement. Yes, this is complement. Yes, what you have read it? A union B complement. That is equal to cardinality of A plus cardinality of B plus cardinality of A union B complement. At least one means what? At least one means A cardinality of A union B. That means what? Cardinality of A plus cardinality of B. Or we can say that cardinality of A union B is equal to N naught A, it means only in A, plus N naught B only in B. For exactly one means only one. That means what? Cardinality of A plus cardinality of B, because A and B are disjoint. So it means what? The N naught A plus N naught B. So from this conclusion, let's we discuss some problems here. Let's set A U is equal to X such that X is the natural number less than 11. There is a set 1 U, and we know that U is denoted the universal set, isn't it? So universal set U is equal to X such that X is the natural number less than 11. And set A is equal to curly bracket Y such that Y is the prime number. It means set A is the collection of prime number but less than 11, because your universal set already U is here, yeah. And next set is B, that is curly bracket Z such that Z is the even number. It means the set B is the collection of even number less than 11. These three sets are given here, okay. Set U, set A and set B are given. So from these sets, we have to write in the sets in the listing method. Then what do you say that set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because less than 11. So up to 10 only. And prime number less than 11 is what? 2, 3, 5, 7. That's why set A is equal to 2, 3, 5, 7. And the even number less than 11 is 2, 4, 6, 8, 10. That's why set B is equal to 2, 4, 6, 8, 10. Now, these three sets, universal set, set A and set B. Now, from these sets, we form the Venn diagram. Let's see the Venn diagram. So, the Venn diagram from these sets is this one. Yeah, set universal set U, that is a rectangle. There are the 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is this 3, 5, 7, 2, and set B 2, 4, 6, 8, 10. Now look at in set A and set B, there is one element is common, that is here is also 2, here is also 2, but here is 3, 5, 7, but there is no 3, 5, 7. Here is 4, 6, 8, 10, but in set A there is no 4, 6, 8, 10, but one element 2 is same. That's why one element is set A also and one element in set B also. Except the elements of set A and B, some elements also now in set U, that is what? 1 and 9, because 1 and 9 neither in set A nor in set B. So it is out of the circle A and circle B. So here is A1 and here is 9. Yes, so like this we form the Venn diagram from this information of the set U, A and B. So these sets are, what type of set is that? Good, that is the overlapping set, because we already discussed before. No, before slides we discussed this is overlapping set, because some part of set A and some part of set B is overlap, where is one element, that is 2 is there. Okay. So in two sets A and B, one element 2 is common element, so these two sets are overlapping sets. It's clear? Okay. Then overlapping sets we can define like this. Overlapping sets means what? If two or more than two sets having at least one element common, there is one element common or not? Yeah. Then the sets are called overlapping sets. So overlapping set is also called the joint set, because join, some part is joined there or not? Some part of set A and set B is joined or not here? So that's why it is called the joint set also. Okay. Now cardinality of set A is 4. Why 4? Look at, in set A how many elements are here? 3, 5, 7, 2, 4 elements. So cardinality of set A is 4. But how many elements in set B? 2, 4, 6, 8, 10. How many? 5 elements. So cardinality of set B is 5. Yes. But 1 and 9 is out of the circle. So how many elements in set U? 10 elements. So cardinality of U is equal to 10. So the cardinality of set A is 4. Symbolically it is written as N A is equal to 4. The cardinality of set B is 5. We will discuss already. So it is written as N B is equal to 5. So the union of set A and B. Yes, union of set A and B. Look at. In the set U and B is how many elements there? 2, 3, 5, 7, 4, 6, 8, 10 or not? Union of two sets. Yes, because one element 2 is common in set A also and set B also, isn't it? That's why that we can, in a set we cannot repeat the same elements. That's why 2 is only one time. Then 3, 5, 7 this contained in set A, and 4, 6, 8, 10 this contained in set B. That's why union is what? 2, 3, 5, 7, 4, 6, 8, 10. So symbolically we can write A union B is equal to curly bracket 2, 3, 5, 7, 4, 6, 8, 10 curly bracket closed. So how many elements are here? 8 elements. Count here. 1, 2, 3, 4, 5, 6, 7, 8. That's why cardinality of union of set A union B is equal to 8. Okay. Now the intersection of sets A and B we already discussed. One element is common. That's why intersection of set A and B is curly bracket 2. So symbolically you can write A intersection B is equal to 2. How many elements here? One element, isn't it? Yeah. So cardinality of A union B is 1. And we can write cardinality of A plus cardinality of B minus cardinality of A intersection B is equal to what? The 4 plus 5 minus 1 is equal to 8. Because number of elements contained in set A is 4. Number of elements contained in set B is 5. And number of elements contained in intersection A union B is 1. That's why altogether 8. So here is also 8, and cardinality of A union B also 8. That's why from this we can write as, therefore N A union B is equal to cardinality of A N A plus cardinality of B N B minus cardinality of A intersection B. N A intersection B. So this is from this. Let's see from here. Yeah, A from this Venn diagram, set A, set B, union means what? These elements, and these elements, isn't it? Yes. And intersection means only one element. Look. Yeah. Okay. Now from the same we can say that, look at now here, set A. Now from the set A, when you subtract this element 2, which is in set B also, then 3, 5, 7 is only in set A or not? Yes? Yes. So it is called what? A minus B. It means what? From the set A, when you minus the elements of set B, which is common, then we get a 3, 5, 7. Yes. So this is called what? Difference of set. So A minus B means difference of set A and B. Okay. So look at now here. Here A minus B is what? 357. 357. So the set A minus B is called the difference of set A and set B. So in difference of set A and B, it means A minus B. How many elements are there? 3. That's why cardinality of A minus B is equal to 3. So it is also known as the only in set A. So it is denoted by n not set A. So n cardinality of set A minus cardinality of say intersection of set A and B means what? 4 minus 1, that is 3. So from this 3, this 2, what we conclude that n not A is equal to cardinality of A, n A minus cardinality of A intersection B, n A intersection B. This meaning is what? The difference of set A and B. It means cardinality of A minus B. Similarly, you can say that here B minus A. So B minus A means what? From the set B, the common element of set A subtract. If this means what? We subtract the 2. Then we left is what? 4, 6, 8, 10. So B minus A means curly bracket 4, 6, 8, 10. So this is called the difference of set B and A. B minus A. That's why B and A. So and it is denoted by B minus A. Yes. And how many elements? 4 elements. Isn't it? And this is only in B. That's why it is called the cardinality. So what is the cardinality of set B only? 4. So it is, what is say that? N not B is equal to 4. Right? And set B, cardinality of set B minus intersection of set A and B is what? 5, 1, 2, 3, 4, 5 minus 1, 4. So we can say that. Now look at here. We can say that cardinality of B is equal to cardinality of B minus cardinality of A intersection B. That is cardinality of B minus A. So this is the other one operation, that is the difference of two sets. Now next is what? In that sets, 2 elements in that Venn diagram is out of the circles, that is 1 and 9, isn't it? So from that 2 elements we found the one set, set 1 and 9, curly bracket 1 and 9. So this is called what? Complement of set A union B. It is denoted by A union B bar complement. Therefore, how many elements are there? 2 elements. So A union B complement set is equal to 1, 9. It contains 2 elements. So cardinal number of A union B complement is equal to 2. But how many elements in universal set U? Please, 10. Yes, 10. So cardinal number of A union B plus cardinal number of A union B complement. Cardinal union is how many elements before we discuss? 8. Now complement how many elements? 2. That's why 8 plus 2, 10. So from this we can say that cardinal number of U is equal to cardinal number of A union B plus cardinal number of A union B complement. Yeah. So this is also the one result. So from this result, from this example, we have to conclude that if A and B are 2 overlapping sets, then the total number of elements of the both sets A and B denoted by cardinal number A union B is equal to cardinal number of A plus cardinal number B minus cardinal number of A intersection B. Second, the number of elements in set A only, n not A, is equal to cardinal number of A, n A minus cardinal number of A intersection B, n A intersection B. Its meaning is what? Before we discussed difference of A and B. So cardinal number of A and A minus B. Similarly, the number of elements in set B only, it means n not B. That is equal to cardinal number of B minus cardinal number of A intersection B. Its meaning is what? Cardinal number of B minus A. From B, subtract the common element A. The number of elements contained in both sets A and B, both sets A and B, that is cardinal number of A union B is equal to n naught A plus n naught B plus cardinal number of A intersection B. If universal set U contains other elements except the elements of two overlapping sets A and B, then we can say that cardinal number of U is equal to cardinal number of A union B plus cardinal number of A union B complement. At least one. Cardinal number of A means what? Cardinal number of A union B is equal to cardinal number of A plus cardinal number of B minus cardinal number of A intersection B, or cardinal number of A union B is equal to n naught A plus n naught B plus n naught A intersection B. For exactly one means only in set A and only in set B. That's why n naught A plus n naught B is equal to cardinal number of A plus cardinal number of B minus 2 times cardinal number of A intersection B, that is contain both. That's why. For at most one means what? At most one, that means complement of A intersection B. Cardinal number of that is equal to NU minus N A intersection B. Now about the subsets. Subsets means what? Look at here. Here is universal set U whose elements are 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there, and from this universal set 2 sets are formed. One set is A whose elements are 2, 4, 6, and other elements is B whose elements are 2, 4, 6, 8. So what you get now here? What do you say that? Yes, all the elements of set A also contain in set B. That's why we can say that set A is the subset of set B. Here set A whose all elements contain in B. So set A is called the proper subset of set B. Okay? Okay. Set A is called the subset of set B. Set A is also called the proper subset of set B. Symbolically, it is written as A subset B. This is the symbol of subset, or we can say proper subset. Okay. Now let's, if set C also form from here, that is 2, 4, 6, 8, then what do you say that? The elements of set C and elements of set B are same or not? Every elements are same, all. So these two sets are what happened? Equal sets. Yes? Okay. Then set C is called the improper subset of set B. Right? And symbolically improper subsets is denoted by this symbol. That's why C improper subsets of set B. So just we review the subsets which you already learned in class 8 also and 9 also. Yeah. Okay, some here one Venn diagram is given. We study this Venn diagram and we have to answer the following questions. This. Yes, look at this Venn diagram. This Venn diagram is the 3 sets, set M, set N and set P. Yes, in set M the elements are 1, 2, 6, 9, 8, 7. So how many elements in set M? 1, 2, 3, 4, 5, 6. Look at in A, cardinal number of M. M means what? Cardinal number of M. How many? 1, 2, 3, 4, 5, 6. So we can say that M is equal to 6. Similarly, in set N, how many elements are there? Look at here. Here 1, 2, 3, 4, 5, 6, 7. So we can say that cardinal number of N is equal to 7. N not P. What is the meaning of this, please? Yes, N not P means what? Only in set P. So only in set P, how many elements? Look at set P is this. But this set, but the elements 3 and 8, that is contained in N also. 8 is contained in M also. But here only. So which element? 10 and 11. So how many elements? 2. Yes. So number C, N not P means 2. Yeah. Similarly, N U P, that means what? Union. Whose union? Set N and set P. Set N means this and set P means this. So in these two sets, how many elements? Look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, in this way we have to count. And can we solve the remaining part? Yes, that is, please you can do yourself this remaining part. Okay. Okay. Now let's we discuss some problems now here, just for fun for you. Let A and B be two non-empty sets. If A and B are overlapping sets, then kernel number of A intersection B is equal to what? Please. A and B are overlapping sets, right? And intersection of these two sets is equal to what? Kernel number. What is equal to this? A, n not A plus n not B, B, n A plus n B, C, n A kernel number of A plus n B kernel number B minus n A union B kernel number of A union B, and D, n A plus n B plus n A union B. Which one is correct? Please. Yes, good. Let's see. We say that C. Yes. Let's see. Yes, very good. Yes, C is correct. Now let's next one. Let A and B be two non-empty sets. If A intersect A is subset of B, A is a subset of B, then kernel number of A union B is equal to what? A is subset of B. Look at. And I told you that, just I discuss with you, this symbol is what? Subset also for the proper subsets. Yes. So proper subsets means what? Yeah, all the elements of set A contained in set B. So that's why, what is this? Please. This is called, what do you say that? In A, kernel number of A, n A, in B, n B, in C, n not A, in D, n not B. Please, which one is that? Please. Which one? B. Okay, let's see. This same correct or not? Yes, very good. Kernel number of B is that. Okay, my dear students, today we discuss some review parts of class 9, and we establish some formulas on the basis of the cardinality of the sets, that is disjoint sets and overlapping sets. Yeah? And today we discuss some problems also on the basis of the disjoint sets and overlapping sets on the basis of cardinality. So thank you for today's class. See you again.